Hi there, you're in the booth with your mate JJ. This is an Elliot's Extras video, second channel. I'm not going to publish this on the main channel because it's just housekeeping. I've got a box full of capacitors which arrived from AliExpress. I blogged about that recently on the main channel. And these resistors also turned up in an electronics kit that I ordered. It was a Arduino Uno R3 kit, and it came with these resistors. So what I'm going to do, I'm going to clean these resistors, and then I'm going to measure and sort these capacitors. So I've got my trusty multimeter here in the back. Can you see that? I think you can. So if we just make sure it's on, it can do capacitors or resistors in this mode. Very good. So the other thing we're going to need is a cloth and some isopropyl. So there's the isopropyl, there's a cloth. We've got 1, 2, 3, 4, and one odd one out. Let's do the odd one out first. So this is, let's have a look here under the magnifying glass. We've got, oh dear, it's either brown, red, black, black, or it's the other way around. Hard to say. Let's measure this one. Let's just put the clips on and let's see what the multimeter says. Multimeter says 220. So 220 is starts with red for 2. So that must be red, red, black, black. 220. Red, red, black, black. It is indeed. Alright, so there's our 220 ohm resistors. We'll give this guy a bit of a clean. He doesn't look like he needs it, but we'll give it a clean anyway. So just fold our cloth together. Make sure he's properly covered in alcohol. Yeah, this guy was in pretty good shape. There wasn't much goo on that at all. Now, is there more red, red, black, blacks? What are those? Those could be red, red, black, black. So good. Those very difficult to tell what we're dealing with here. We'll measure them again. So I'll just put those away for now. Hi. Alright, here we go. What do we say for this one? Can you see that multimeter? You can. Alright, it says 10K. 10K. Alright. So here's 10K. Should be brown, black, black, red. Just confirm. I've got brown, black, black, red. Yeah. Very good. Alright, so we can clean these up. And we need a rubbish bin. Let's get the rubbish bin over here. Alright, so just oh dear me. I might time lapse the rest of these resistor cleans. Alright, so that does that for the resistors, and up next is the capacitors. So I'm just going to start at the big ones, I think, and work our way back to the small ones. And for each, I'll just see if those legs are magnetic. They are. Excellent. So I might use my little steel metal container, or not. Am I going to use my steel container? I don't know. Probably don't need it. So they're labelled on the front, so it's 104, and we're just going to take one and measure it. And then after we've confirmed that the readings are within tolerance, we'll oh, okay, this multimeter doesn't look like he can do it. I want you on capacitance mode, please. It says mega ohm. It's not reading this capacitor at all, and this was one of the larger capacitors. So interesting. That's the first time I've tried to do that with this multimeter, so it turns out you can't do it. I have other options. This is an ESR meter, but what we just want is just a capacitance meter. There's a capacitance meter. Now I'm not sure how small it can measure. Does it have a spec on it? Let's turn it on. Okay, initializing. Oh, it's saying picofarads. So can you see that screen? Can you? Barely, I'm not sure. If I take that away, is that better? Yeah. Well, I'll call it out to you anyway. So let's see if this special purpose capacitance meter can measure this capacitance. Doesn't look right, does it? 104 shouldn't be 56 narofarads. 104 should be 0.1 microfarads. Let's just keep measuring them, because it could be the reader's wrong, but it could also be that the capacitors are dodgy, because who knows what you get when you buy cheapo capacitors. This also says 45 nanofarads. That's nothing like what it should be reading. Oh, there we go. Look, it says auto 0. Okay. If we clip them together and 0. Oh, you need to open to 0. Alright, we've zeroed. Now let's zero again. Alright. Okay, so that's 0 to 47 nanofarads. That's not what we want. 47 to nanofarads. Yeah, that's what we want. Alright, let's see if we can get a better reading this time. I hope we can, because otherwise either the meter's dodgy or this says nanofarads again. It says it's 0.06. It's not even close. Let's pick another one at random out of the pile. And it's saying 41 nanofarads. I do not know what we have here. but I don't think it's good. Let's try one of the ones out of the thing and see if they give a proper reading or not. Yeah, okay. There you go. Wow, these capacitors are shit. Let me just pick another one at random out of here. Who knows what I've got here? How disappointing. Alright. Still, buy cheap, buy twice, right? Okay. That's saying 65 nanofarads as well. I'm not sure. I'm going to get a second opinion. I'm going to get rid of this guy. I'm not sure if I believe it. So what else have we got? We've got this component tester. We can give him a go. And pop him open and turn him on. Alright, component tester, that's good. Alright, now we're going to put in, let's put in the one from before, or one of them from before. This should give us a reading of 100 nanofarads, which is 0.1 microfarads. So, test. There we go. Okay, so it says 85.1, which is kind of close, I guess. Let's try another one. And this. And test. $94.7, that's pretty good. Oh shit, I just dropped it in the thing. It's alright, you can tell it's different coloured. Alright, let's try one of the new ones and we'll see how they fare under this meter. Alright, test. 45. It's just not, it's, does anyone know, is this what I should be seeing? Like for 104 capacitors, they shouldn't read 45 nanofarads. Yeah, 45, 45. These are rubbish. Test. Well, whatever they are, they're all the same. They're basically just labelled wrong. Alright, well, I'm not going to put them in. I'm not going to put them in. I'm just going to keep them out. And we'll test a couple more of them just to see what the rest of them are like. Let's test one from each end, from each edge. Alright, so that said 45 when it should have said 100. So let's try one of these guys. Now, what do these say on the tin? 472. 472 should be 4.7 nanofarads. 4.7 nanofarads. Alright, we'll test that. Okay, that's close. It's given it to me in picofarads, but it's 5.6, which is kind of close, isn't it? Okay. 5.6. It's close to 4. Let's try one more of those ones. Let's try one more of you. And you. Alright, let's test him. Okay, that's 7. Close. Close. So, I might just also just try the capacitance meter again. Let's see if we get the same. And we might as well try the 0U. Up you come. Oh, I turned it off. Put this guy on. We got all of our ducks lined up. Now, why isn't he going on? There we go. And this guy. Now, I'm not sure what you can see, but I'll call the readings out to you. So let's try the capacitor meter. By rights, this should be the most accurate bit of kit. It's special purpose capacitance meter. Okay, 7.2 nanofarads, which is pretty close to what we got on the capacitance tester. So we're looking at about, what are we looking at here? Can't read it. Yeah, okay. So it's basically, it thinks it's a resistor and it's a really high valued resistor. Okay, so the digital multimeter is not going to help us at all. Well, I have to say those are pretty shit probes. I wonder. Should we try with better probes? Why not, huh? So let's try that probe and that probe. And just hook him on. I'm not expecting this to work. Alright, capacitance meter says open line, thinks it's a high valued resistor, and it's not, so we'll get rid of that. It's not helpful. And let's just confirm. So the capacitance meter says 7 nanofarads, and the component tester says 7,400 picofarads. So, okay, they're not all as bad. I'm going to pause for a bit, I'll be back. Alright, here we are again. So I'm just going to keep on testing. I'll test the next one in line. Now, the documentation says that these are 470p. Now, 470p is just 470. 470. I'm not sure what 470 is. .470p is 471. Oh, yep, 471. Okay, good. 471. That's what we've got here. So let's have a read of this one. Okay. Close. Close. Much closer than the other ones. And we'll test him. Should be 470. Says 304. Sort of close. 306. Okay. What are we gonna do? Okay, it can't read that part. It's too okay. Let's put the range. Okay, this can do 0 to 47 nanofarads. It's 33 picofarads. It's a very small resistor. Capacitor, I should say. Wow, that's giving a pretty good reading. It says 40 picofarads, which is pretty close to on the money. Gee, I'm not sure what I should do. Let's try some of the larger ones again. The second one's along a 683. Now 683 is 68 nanofarads. 68 nanofarads. So we'll put him into nanofarad to microfarad. And what did we say this was? 683. Should be 68 nanofarads. Pretty close. 77 nanofarads. It's only the really big ones that seem to be well off. So let's try this guy. It thinks it's a resistor. Dear me. A very high valued resistor. It's not. Still says resistor. Fascinating. Yep, it's only going to give him a resistance value, which is odd because the other meter got it correct, didn't it? It says 81 nanofarads, which is close. It's supposed to be 68. 68. 83. Pretty close. Let's try one more out of that box. What have we got there? 77. 78. It's going up as it heats up. 81. Still. It's roughly about right. Look at it going up, 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 up. When's it going to slow down? The temperature must be really affecting it. It's just going up, 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 up. Wow. Wonder when it'll stop. The capacitance is changing quite a lot. Going up to 90. 91. I wonder if we touch it, brings it down, changes the capacitance. I think because I'm sucking the heat out of it, I'm basically a heat. If I let it go, it should start to go back up. Look at it rocketing up. Fascinating. All right. Well, let's try the big ones again and see how temperature affects the reading there. On we go. Alright, starts at 52, 53, 74. Now it's supposed to be 100, right? 100. It's gone up to 56. It's going up slowly, 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 slowly. Wow. Slowing down a bit now. It's just about to hit 57. Which is about half what it's supposed to be. A bit more than half. Still going up, but very slowly now. There we go, slowing right down. Ah, interesting. It's not quite in the right order of magnitude though, but it is within half. There we go, pretty maxed out. Maxed out at 57. Let's just pick another one of these guys. It says 683, that's what we want. $683, which is 68, and this is 74, which is pretty close. Close enough. I don't know what kind of tolerance these are supposed to have. 24 by 40. I don't know. I can't read the Japanese. I don't know what it says. Japanese, Chinese. I think it's Chinese actually. Alright, well that seems reasonable. Let's just keep measuring. We'll measure 2 from each. Yeah. Let's put it on auto ranging. There we go, it's on auto ranging, and it's picking up about 50 nanofarads. 47, 50, very close. I'll take that. And let's do one more. $473. $473. Yep, 52 nanofarads, I'll take that. Alright. Now, what does it say? Got well and truly bent this one. 223. So it should be 22 nanofarads. What do we got? 27 nanofarads, that's pretty close. And that's 25 nanofarads, that's also pretty close. This is 103, so it should come in at 10 picofarads. Nanofarads, of course, 10 nanofarads, yes. Very good. And so it only seems that at the very top end, the resistance is quite out, but these ones are pretty reasonable. They're very close to spec. Yep, 10 nanofarads, pretty happy with that. Now we did these ones earlier. So these should be, what did it say? 472. So it should be, yep, 6.7. That's pretty close to 4.7. And then we've got this guy. Now what does he say? He says 332. Is that right? 332. So it should be 3.3. Yep, that's pretty close. That's 2.8 nanofarads, or 2000 and something picofarads. That's right. And this guy. Still on auto ranging. What have we got here? 2000, 2.2. Sounds about right, doesn't it? Yep, that's 222. And 222. Yep, good. And this is 1.2. Should be 1.5. It's heating up. It's going up. It's 1.3 now. So that's pretty close. I'm happy with that. And then we've got 102. 102. So that should be just basically 1 nanofarad, or 1000 picofarads. That's pretty close. 1.3 nanofarads. 102. 102. And then 670. This is 681. 681. Yep, pretty close. It's 620. And then half to go. This is 470. There we go. 500, I'll take that. So I think I have to make a note to self, which is when taking ceramic capacitors out of these drawers, just check them, because some of them aren't quite exactly in spec. And sometimes it probably doesn't matter very much. Alright, this is 4. Oh shit, I forget. 331, pretty much exact. Yeah. So what I'm looking at? Oh. 331, yes it is. 331. Alright. And let's just have a look here. This one. Alright, what are we dealing with here? This is 221. So let's see what it says. 221. Very close. 237. I'll take that. I'm looking forward to getting myself the Peak series of component testers. Have you seen those? The Peak? They're really excellent, but they're expensive. I think they're made in the UK. I'm not sure. I haven't got any of them yet. When I'm rich, I'm going to get the full set. Okay, that's 122. It's supposed to be 100, so 122 is pretty close. Let me just check the markings on this one. 101. Yeah, so it was supposed to be 100, and it was pretty close. And then this guy. Well, I'm glad that in the large, this capacitor box is not a complete write-off. I can actually relatively confidently file all the pieces. It's just the 100 nanofarads. Doesn't seem quite right. 68, this is 89, that's pretty close. And then 47. Now this is 47 picofarads. It's very small capacitance. And it's measuring 58, which is very close. Alright, let's keep on keeping on. We've got 6 more to do. There we go. Now this is 33 picofarads, which is almost negligible amount of capacitance, isn't it? Oh, you could find that much in a wire. Alright, 44 picofarads, I'll take that. And then what are we doing next? 22. These are very small capacitances. Okay, 22. Is it 22? Let me just check. This says 30. 30. Okay. Well, let's just see if it is actually 30. 43, pretty close. Let's take this one now. This one was supposed to be 22, I believe. Yes, 22. It says 22. I'm happy with that. 33, 32, close enough. And then what have we got here? Damaged. Maybe 10 picofarads. Gee, that's small. It says 23 picofarads. Pretty close. Yeah, I suppose these flimsy little capacitors, you know, they're roughly within half. That's probably good enough. 15 picofarads, that's for a 5 picofarad. Yep, fine. And then the final one, 2 picofarads, which is silly. This is measuring, I'll zero that. Okay. And that says 2 picofarads. I think actually I hadn't had it properly calibrated, which is probably why those other readings were a bit off. So let's zero that guy again. And then after he's freshly zeroed, let's try one of these that are supposed to be 100 nanofarads. It's on auto ranging. Let's see what it says. Oh dear, I've dropped it. Can't take me anywhere. Found it. I'm going to zero that again because it's floating. Takes a long time to zero, doesn't it? Alright. Look at that. Okay. So, let's see what he says. Again, it's only about half of what it's supposed to be. But we did say about half is about right, isn't it? Alright, fine. I'm going to file these. The high value one seems to be really quite off. But, you know, pretty close. Within an order of magnitude. I'll just turn this guy off. That was my component tester. Alright, fine. So, 104. 104. Which is pretty much maxes you out. That's the largest type of capacitor I have, is the 104s. Well, they're all mixed in there now. But I can always check, can't I? If I want to know for sure, I can test. And then the next one is 683. 683. And here we go. I'm going to time lapse this. And that's it, we're done. So I'm going to go and put this container in the container box, and I'll get this video released onto the second channel for anyone who's interested in watching me sort my resistors and sort my capacitors. So thanks very much for watching, and please remember to hit like and subscribe.